Have you heard of 3D Gaussian splatting and wondered how you could create your own splat using your own images and then maybe create a website to display that splat? Well, I'm going to show you how. So it's really quite simple using React 3 Fiber. This is all of the code we're going to write today. It's only 26 lines, and it gives us this whole viewer here, and we can zoom in, move around, rotate around the mailbox. All kinds of cool stuff. And don't worry about the crazy look of mine. I just used 20 random images I had. You can make yours look a lot better if you use slightly better images than I did. So let's get started. So the first thing you need to do is just collect all the images you want to use to create your splat. Here are the 21 images that I used. They're just a bunch of random pictures of this black mailbox that is outside of Area 51. It's kind of a tourist attraction that is out there. It's kind of cool to see. There's apparently a new one every couple of years because people steal the mailbox and then it gets replaced by somebody. I don't know who. So I just went out there and took these pictures. I didn't really know what I was doing, so I just kind of walked around it and took pictures from different angles. To get good results, you probably need a bit more images than this. I would maybe shoot for like 100 or even more than that of different angles, different heights. A lot of people I know are doing this with drones so that they can get like a really comprehensive coverage of whatever it is they want to make a splat out of. This tutorial is not really about how to do the photography aspect of it. It's more about just once you have your images, how would you go about creating a splat file and using it in React 3 Fiber. So let's move on to the next step where we're going to take these images and convert them into a splat file. So now that we have our images, we're going to use PolyCam to convert them into a 3D Gaussian splat. And PolyCam is pretty cool because it's really simple to use. I'll put this URL in the description, and all you'll need to do is go there, click create a 3D Gaussian splat, and then upload all of the images that you want to use. The free version only lets you use up to 150 images. If you have more than that and you want to make like a really big scene, because with Gaussian splatting, you can even make scenes you can walk around and move around in, but you even need more images for that. You can also do the paid version if you feel like it. But for the free version, we'll just do our 20 images here, which is well below the limit. And we will call this Area 51 mailbox. And then you have to make it public if it's free, which isn't a big deal for this. I'm also going to click this sequential toggle, and I assume this is just some kind of optimization for the processing of the images into a splat. Probably just gives it a hint that each image is probably close in position. So we're going to do that and then just hit upload and process. This will take a moment to upload everything. And then once it's uploaded, you'll also have to wait for it to process for a little while. And that processing will happen in the PolyCam sort of dashboard here. You'll see this is the one we just uploaded. This one is the same set of pictures, but just a previous run that I did. And so what you will kind of experience is that once your upload is done processing, it'll just appear here with a preview, and you can open it up, preview your results, make sure everything kind of looks the way you expect it to look. And then finally click download, select splat, and then download that file somewhere. Just make note of where you download it to, because we're going to use that file in the next step. Here's my output file downloaded from PolyCam. It is a PLY file type, and we need to convert this into a splat file type in order to render it in the browser using the WebGL implementation. This is the repository for the WebGL implementation of a viewer for Gaussian splats. And under the hood, this is what we're going to end up using in React 3 Fiber to render the file. And this repository happens to contain a very helpful converter written as a Python script here that we're going to be able to use to convert a PLY file into the splat file format that the viewer will expect. So we're going to clone this repository, mostly just to get this convert.py file. And I'm going to do that in my terminal here. So we'll just run git clone. Change directories into the splat directory. And then we're going to need to run that convert.py file with Python. So you'll need to have Python installed for this. You'll also need to have Git installed for this. I can post links to some documentation about how to do that, but I don't want to cover that in the tutorial. So let's get our PLY file here. And I'm just going to move it directly into the directory with the convert.py file. So once it's in there, it'll be easy to just run Python convert.py, and then we'll give it the name of that will process it, and in a minute or two, we should get some output with our splat file. So after a while, you'll get this output.splat file, and the script will be finished. We can check that file out in the same directory as the repository. And these files are pretty big, so depending on how many images you used, it might actually be too big to host on a normal web host, or in our case on Code Sandbox. So something I've been seeing a lot of people do is upload their splat files to Hugging Face, which lets you host really big data set and machine learning model files. So they have this data set category, which is kind of the perfect place to put a splat file, since it technically is like spatial data. So I don't feel too bad about that. Sign up for an account on Hugging Face if you don't have one already. And then once you are logged in, you'll be able to click on your profile icon up here and go down to new data set, create a data set name, give it some kind of a license, leave it public so that it's accessible to everybody. Click create data set, go to files and versions, and then you'll be able to add a file here. We're going to upload a file. All right, so then you get this upload files dialog. I'm just going to pull up our splat file here, drag and drop it into the little box. Yeah, so that should show up right there. And then you can just leave all of these settings the same, leave the commit message, the default, that doesn't matter, and hit commit changes to main. It will upload that file. It'll take a little bit of time, but not too long. And then once that is done, we'll have a place to reference this file from. And so that's kind of the end of the processing part of this. We can now move into React 3 Fiber and build out our viewer. Okay, so let's build out the React app for viewing our Gaussian splat. I'm going to use Code Sandbox to build this, and I will share out the finished project. So if you just want to jump into the code and take a look, it'll be linked in the description. And if you want to follow along, just go create a default React template app in Code Sandbox, or create a React app locally if you want to. Just get a React app up and running, and everything else should be about the same. All right, so the first thing we need to do is install the React 3 Fiber dependencies. We're going to install React 3 Fiber and then also React 3 Dry, which is a bunch of different helper components and very useful things for making React 3 Fiber apps easier to build. So let's do that. First, we need to actually install 3 itself, which is a pure dependency of React 3 Fiber. And then we need to get React 3 Fiber, React 3 Dry, This is how you do that in Code Sandbox, but if you're using NPM and running React locally, just use NPM and make sure you save it to your package.json. So once we have those dependencies available, we can start building out our React 3-fiber app. And we're going to start by importing the canvas element, which is the root of every React 3-fiber scene. So it's the first thing we need. Grab that here. And then we'll replace all of the boilerplate with a canvas app. That is save, just to kind of set ourselves up for a clear canvas. And that's that part. So next we need to actually grab the splat component from dry. And the splat component is where the magic is going to happen for this whole project, because it's basically just going to do all the work for us. It is pretty much just a wrapper around that GitHub project we looked at earlier, Antimatter 15's Splat repo, where they actually implemented the real WebGL implementation. So this component is basically a wrapper around this project. The only docs we are going to need to reference, though, are the dry docs for the Splat component. So we're going to just look at this Splat props type, and this is going to tell us which props we have available to configure the Splat component. The source is the only thing we really care about right now, and that is, as described here, the URL that points at a Splat file. And since we know we already have a Splat file uploaded, that's probably what we want. So back to our canvas here, we're going to add a Splat component. I'm going to import that from dry. If we save that, it'll say could not load undefined because we don't have any source. So we're going to add a source. And so this source needs to point at that Splat file we uploaded earlier. And the way to get the URL from Hugging Face that we need is to go check out this download button here. And if you copy this link address, this should be the right URL. So come back here, put that in. I don't think we need this search param here, so we'll remove that. Give it a save. And something happened. It doesn't look very good yet, but we should be able to fix that right up. One of the first things that I think we should do is probably go into our CSS here and make it so that our canvas fills the entire screen. And just do canvas, body, 100%. Inspect this and see why it's not. Because the root needs to be 100% too. So we will also make that 100%. Okay, so there we go. Now it's filling up the whole screen. We can also remove padding and margin. That's better. Okay, so let's figure out why this looks so crazy. And one way that we can kind of check this out is to maybe just add a little bit of camera control to our scene. So I'm going to also import orbit controls from dry and then add that to the canvas. And orbit controls are going to let us drag and move stuff around. And so that is useful because it tells us what's happening is that the rotation of the scene by default is sort of all wonky. We're actually underground, and this data is kind of junk data. It's not like we have any actual pictures from under the ground. But if we rotate things around, we actually get a pretty decent look here. So let's handle that by just like, maybe we can rotate the splat so that when it loads, it's in the right position. So let's take a look at how we can do that. Since this splat component is more or less regular React 3 fiber 3JS geometry, it also has a rotation prop on it that we can use. So for the rotation, everything's going to be in radians. So we're going to use math.py to control the rotations. And we'll just throw something in there for a minute. I'm going to also refresh this just so we get back to like the default rotation here. Okay, so we're still underground here. So I'm going to try tweaking these numbers. And I happen to already know what the right values are, but we're just going to rotate this around in different ways. So this is the X rotation. And then I'm just going to give it a very tiny amount of Y rotation. And do 1.25 math.py. All right, so this will allow the scene to load in a kind of more normal orientation when it first starts up. And I mean, depending on what you want, this could be fine. We're kind of zoomed out here. I actually want to be a little bit closer in to the mailbox. So we also have some ways to do that using the orbit control props. The orbit controls have all kinds of different props, but let's start with one useful one that is called max distance. So if we set a max distance, that's going to keep the camera constrained to some maximum distance from the origin. And so now if I try to keep scrolling out here, it just stops. And we can mess around with that to find a number that we like. Try, I don't know, let's get really close. Let's try like 0.5. There we go. So now I can't zoom out any farther than this. I mean, depending on your aesthetic preferences or whatever your scene is, you can do whatever you want. But the idea is we want to kind of like control the camera so that you can't put it into wonky positions. To maybe demonstrate that a little more, if I make the max distance bigger, maybe I don't want the user to be able to like see this crazy part of the splat, or maybe I want to hide like some of this really junky quality portion and like just have them be able to look at it from a constrained angle. We can do all of that. So let's keep our 0.5 for max distance. We'll stay in close. I could zoom in forever though, so maybe we don't want that. Let's also do a min distance. And I think maybe like 0.3 might be good for this. Yeah, so 0.3 means I can't zoom in any farther than this, which if we rotate around, it's pretty good. You can still see the whole mailbox, but you can't navigate inside of it anymore. All right, so we have some nice control of the distance the camera can get from the object. And we might also want to control the rotation or angle of rotation that we can see the object from. And I mean, that's pretty useful, especially in this scene where there's a lot of like broken views. Maybe like we have something good enough to give a 3D effect, but we don't want to let the user rotate all the way around. Well, we can do that too. And I'm going to show you some of the properties of orbit controls that will let us make that happen. All right, so let's pull up some more props here. And one place you can find all of these is if you look at the orbit control docs on the 3js.org site, all of that information is available here. You can just look at the various properties of the class, and you can find everything you need. So we already used max distance. Well, we'll see there's also max polar angle, and that's how far you can orbit vertically. Upper limit range is 0 to math.pi radians. And by the way, math.pi radians is exactly 180 degrees, and radians 2 pi is 360 degrees. So this is kind of saying from like rotated all the way down, kind of like this, to all the way up here. So let's actually try that out. So if we take this max polar angle here and set that math.pi times 1. Well, this isn't going to do anything, right? Because it already said that that's like 180 degrees. But if we start to tweak that, so let's just start at 0.5. Now suddenly we can't rotate down anymore, which sort of tells you that this must be 0 radians of rotation. This angle right here is 0.5 times pi. So if we wanted to let the user go a little lower, I do 0.75. It's pretty good. We could also set the minimum. So we can do min polar angle. And if these are the same, that's more or less just saying you're locked into one plane of rotation. And that could be a cool effect. You might want that. But if that's not what you want, you could also maybe let them go from here to here. It really just depends, whatever your scene calls for. Okay, so now that we can control polar rotation, there's just one more thing that we probably want to talk about, which is like, what if I want to control this rotation? I don't actually remember what that is called, so let's go back to the docs and look this up. So this looks promising. There's min azimuth rotation, how far you can orbit horizontally, lower limit. Be then a max azimuth angle. Okay, so that looks like what we want. Let's try to play around with those until we get an effect that works for us. So let's start with the min azimuth angle. Let's set that to basically what we know to be 180 degrees. Also do max. Sometimes it's kind of helpful to set the min and the max to the same thing, just to like figure out which angle a certain position is. So like this tells me that this view is rotated in 180 degrees. So that is a nice helper. So let's see then, let's say we want to look at the opposite side of the mailbox. So if we want to go another 180 degrees around, so it would probably be times 2. Yep. So that's a way to kind of like think about these radians. Just whenever you increase the number by pi, you're going 180 degrees around. So I'm going to kind of like stay on this angle since things look pretty good. We don't have a whole bunch of blurry, messed up stuff. So let's just give the viewer like a little bit of leeway to each side so that they can actually experience the 3D-ness of it all. Other than this little bit of zoom and a little bit of up and down rotation. Let's also let them say do like 1.75 to 2.25. Now you can do this too. And there we go. So that is pretty much it. One final thing I'd like to show you just to sort of prove a point is that since this is our own viewer and it's just a regular React app, we could combine this canvas with other regular HTML elements. So maybe, for example, I want to have like a h1 tag here, a title. Do that. So I can add that, which looks stupid, but let's maybe overlay that over the rest of the scene. I'm going to do that by adding a div around it. And then we'll go into the CSS in a second. Yeah, so then with that title class, we can just display flex, position, absolute. I think by default, the canvas element is higher up in the layer, so it's on top of our tag now. So let's add a z index to this. There you go. So now we can see it again. And since this title, remember, is a div containing the h1 tag, we can make the div itself fill the whole screen. And then we can use our flexbox to position that tag in the middle. Oh, just got a typo there. And I'll just copy and paste the rest of the CSS in here. Let's also give it a better font. Yeah, there is our website rendering a Gaussian splat. I hope you can use this to make something cool and better than mine with my kind of crappy splat. I've seen some really crazy ones where they scan like a whole house or a whole area of like rocks and boulders, and you can make really big splats where you can walk around a whole scene. So just let your imagination run wild and go repeat this process with whatever images you can come up with, and have a good time. Bye.